In this lecture, we will see the layout of a 2-input XOR gate using 2 transmission gates that is drawn from the twisted schematic by using the toolbar. In order to open the terminal window, press Ctrl Alt and T, then type magic, press enter. Now when we want to use the toolbar, we have to go to options, then toolbar. So this will load the tools. In order to grid in, press G in your keyboard. In order to zoom in, press Z. Now since we are using 2 transmission gates and 2 inverters, so we have 4 PMOS and 4 NMOS. So we can have a common N-well for this. We can have a common N-well. So go to N-well and then middle click. Then we need 4 P diffusion layers. So this is one, or we can take like this. This is one. So if we have a gate here, okay. This is one. Go to N diffusion, sorry, P diffusion. This is one. Then over here, the second one, P diffusion. Then for the third one, you'll have some space. You can do it from here. Then middle click on P diffusion. Then go to N-well, then middle click. Then select the same area. So still it's not sufficient, so we have to extend. Then middle click on N-well. So I have this common area. And then middle click on P diffusion. Of the same area as the P diffusion, we need the N diffusion layer to construct the NMOS. So middle click on N diffusion. Then again we will click on N diffusion. This is N diffusion. Okay, you have to undo and then middle click on N diffusion. Okay, now these two are my transmission gates, these two are my inverters. So before designing the transmission gate, we need the 2 inputs, that is A and B, and their inverted forms, that is A bar and B bar. So first construct then middle click on poly. Again middle click on poly. So these two, they form the gate. Now we know in the inverter the sources are shorted and drains. The sources of the PMOS are shorted to VDD, the sources of the NMOS are shorted to ground. So middle click on M1, then here again middle click on M1, then select from here to here, again middle click on M1. So I've taken squares, 4 squares for this. You can see 4 squares. Then middle click on M1 again. Similarly over here. So the VDD and ground, they're connected. Since the inputs are the gates, the output is taken from the drain. So short the drains. This is M1. Again this is M1. Okay, now this is A. The inverted form is A bar. This is B. This is B bar. So if you want, you can even name it. Middle click on poly. Middle click on poly. Here you have to middle click on M1. Okay. Now let us label this as A. Type label VA. This is VA bar. So label VAB. Similarly, this is input B, that is VB. V is for voltage actually. Now this is the inverted form of B. So label VBB. Okay. Now after labeling this, you can even label this as VDD. And this as ground. Between ground. Now this input A, okay, before going for the connections of the input, we have to join the gates. The gate of PMOS1 is connected to gate of NMOS2. The gate of PMOS2 is connected to gate of NMOS1. So middle click on poly. Again middle click on poly. Then from here to here, we'll click on poly. So these two gates are connected. Now we'll click on poly. Now we'll click on poly again. Middle click on poly. Connect from here to here. We are basically trying to connect the gates. Then again poly. Okay, now if I press Shift Z, you can see this is connected over here and this is connected to here. Okay, now these are the transmission gates, right? So when these are the transmission gates, the sources and the drains will be shorted. So simply short the sources and the then middle click on M1. Similarly over here, middle click on M1. The sources and drains have to be shorted. Okay. Now, what we have to do next? This is A and this is A bar. This is B. This is B bar. These two are B, these two are B bar. So if it's A, okay, before connecting A, do one thing. Connect the two drains. The output okay, now middle click on M1. These are the inputs, right? This is the output, the connection of the two drains. Okay, this is A. This A is connected to here. Okay. So one thing can be done. We can remove this and we have to place upwards. So middle click. We'll connect this poly later on. But at first we have to connect the inputs. Then we'll click on M1. Zoom in. Okay. Now middle click. So if we are trying to connect, then connect it completely. Poly. So you can see this is a connection between the metal and the poly layer. So we'll place a metal contact over here. Before that, middle click on poly. Okay, now just place a poly contact, select the area, and then this is the poly contact. Middle click on poly contact. After that, after placing the poly contact, this is B. After connecting A, you have to connect B. So this B, this one is B. This B is connected to B. So middle click on poly. Middle click on poly. Again middle click on poly. So this is connected to B. Then the second transmission gate, it is A bar B. So this is connected to A bar. A bar is this. Middle click on M1. Middle click on M1. Then connect from here to here. Again M1. Okay, so this is connected to A bar. Then the gate is connected to this connected one. This gate is connected to B. Okay, made a small mistake. This has to be omitted. This one is connected to B bar, not B. This is connected to B. So first connect the B1, middle click. Then from here to here, it's B. undo, okay. So again here you have to place a poly contact. Since again there is a metal end, this metal and poly, metal and poly overlapping. Okay. Now after all the connections are done, inputs are placed, VDD ground, output. This is the output. So type label Vout. After all the connections, we have to place the contact. So we start up with this one, the P diffusion contact. Select the area, go to PD contact, then here again selected the area, then middle click on PD contact. So you have to place all the PD contacts. We have already placed the P diffusion contact, so here you have to place only the PD contacts. Now similarly place the PD contact over here. This is the last inverter, so place, then middle click on PD contact, again here PD contact. Now after placing all the PD contacts, we have to place the ND contacts. So zoom in the N diffusion layers, place the ND contacts. Once you have selected the area, every time you click you will get the same area. ND contact, this is the ND contact. I guess you have one more. Okay. After placing the ND contact, we have N substrate contact. Shift Z. This is the VDD. So this is P substrate contact. Then over here you have the N substrate contact. Okay, so I've placed all the contacts. Now type save XOR 3. Okay, XOR 4. DRC fine, no errors. So extract to spice, extract to sim. Now after extracting to sim, type irsim XOR 3.sim. Then watch VA, VB and Vout. Display all 0. Now what will happen to XOR if I give low value to VA and VB? 0 0 0. Any input given high value will give output as high. See 1 0 1, output is 1. Now if I give high value to VB, that is 1, then the output will be VA1 VB1, output will be 0. output is 0. Now initially I had given high value to VA, then VB, low value to both. Then again if I want to give low value to VA, output will be 1 again, 0 1. If I give high value to VA, low value to VB, output will be again 1. If I want to see it in an analyzer, I'll type ANA, VA, VB, Vout. So I'll go to zoom and full. This is 0 0 0, 0 1 1, 1 1 0, 1 0, 1, 0 1 1, 1 0 1. So this is the waveform and this is the layout. You can see how complex is the XOR gate since we have used the transmission gate. This is the layout. Now if I want to see my spice file, I'll type exit, then vi spice XOR3.spice. Okay, if I want to open it, the magic file, I'll type magic XOR3.mag. Now zoom in, zoom in. So this is the final layout of a 2-input XOR gate by using 2 transmission gates. It's from here to here, here to here, and these 2 are the inverters. Now let's see the layout of a 2-input XOR gate by using transmission gate that is drawn from the normal schematic. So open the terminal window by pressing Ctrl Alt and T, then type magic, press enter. Now this is the layout window and this is the Tikicon window. So we have 2 ways. So we can draw the layout either by using commands or from the toolbar. So we'll use toolbar. So first go to options, then click on toolbar. So after clicking toolbar, you can see all the layers over here, the tools, the N well, this is N well, P well, this is N diffusion, P diffusion. Similarly, the contacts are placed over here. You can see a cross mark over the contacts. Okay. Now in order to grid in, we used to type grid, but here we will press G in your keyboard. So when I press G, got all the squares. If I want to zoom in, I'll just press Z. If I want to draw layout from the untwisted schematic, then first I have to place the PMOS and NMOS. So first the PMOS. Suppose this is the N well, select the area and then middle click on N well. Okay. Now we need 2 inverters and 2 transmission gates. So what we will do, just place the gaps. Okay, this is one PMOS. We have the second PMOS. So then middle click on anvil. We are placing two inverters side by side. We're drawing two inverters side by side. Now after drawing the anvil, select the area for P diffusion. After selecting, middle click on P diffusion. Similarly, of the same area, we need a P diffusion over here. So middle click on P diffusion. And of the same area, we need the N diffusion layers. So just place it a bit below. Then middle click on N diffusion. Similarly, over here, select the area and then middle click on N diffusion. Okay, we need uniformity basically. So in the inverter, we have the PMOS and NMOS gates connected. So connect the PMOS and NMOS gate. Middle click on poly. Similarly over here, middle click on poly. You can select from here to here. Then again middle click on poly. So these two gates are connected. Similarly, we'll connect these two gates. Okay, we'll keep it a bit closer. Middle click on poly. From here to here, middle click on poly. Middle click on poly. Okay, so the inputs are ready. Then the output is obtained from the drain. So in this PMOS, this is the source, this is the drain. In this NMOS, this is the source, this is the drain. Similarly here also. So the sources of the PMOS is connected to VDD, the sources of the NMOS is connected to ground, and the drains are shorted. So we'll do the same thing here. We'll short the drains. So select the area. And then middle click on M1. Either you can make it as 4 or you can make it as 5. Here I have taken 5. Similarly over here, just for uniformity, I am taking 5 width, and then middle click on metal 1. Now the drains are shorted. Then we have the VDD and ground. So select the area and then middle click on M1. Similarly over here, middle click on M1. So these two, they are connected to VDD. So select the area, 2, 3, 4, 5, 5 width, and then middle click on M1. So these two are shorted. Similarly over here, over here this is 5, middle click on M1, from here to here, middle click on M1, similarly over here, select area and middle click on M1. Now just zoom out and see how it looks like. This is one inverter, this is one inverter, this is input 1, input 2, that is this is A, this is B, this is the inverted form of A, this is the inverted form of B. If you want, then we can do the labeling now also. For example, this is poly, so middle click on poly. Similarly over here, okay, I'll do one thing, just undo. What we will do, we'll place input over here, middle click on poly. Similarly over here, middle click on poly. Why? Because you have seen in the lecture about the schematic diagram, we have to make some more connections over here. So just to provide space, we have done the input over here. In this case, middle click outside. Okay. Remove this. We can directly take. If we want, then we can directly take from here. We need not extend it and then take it. Okay. Now this is A. I'll just label this as A, VA, and this is the bar of VA, that is VAB. This is VB, and this is bar of VB. So label this as VBB. Okay. Now what next? After drawing the inverters, we have to draw the transmission gates. Shift set. If you want, you can do the labeling for VDD also. Label ground. Okay. After VDD and ground, in order to draw the transmission gate, in transmission gates, the PMOS and NMOS, they're placed in twisted form, but not like that in the twisted diagram. The gate is faced, the gate of the PMOS is faced upwards and the gate of the NMOS is placed downward rather than facing each other. So let's draw the transmission gate. One will be placed up in over here and one will be placed below. So select, okay, let me take this area. Okay. Place it over here and then middle click on anvil. This is for one transmission gate. We'll leave some space for here we can place the P diffusion layer and diffusion layer. Then over here place N well, or just a bit above this. Middle click on N. Same over here also. We'll just place a bit below. Then for P well, zoom in, select the area, and then middle click on P diffusion layer. Then over here also select the area and then middle click on the P diffusion layer. Now after drawing the PMOS, you can place the NMOS, middle click on the N diffusion. Similarly over here, middle click on N diffusion. Okay, so you can see inverters, your transmission gates. Now what is the pattern of the transmission gate? Their drains are shorted, sources are shorted, and drains are shorted and the sources are shorted, and the control input is given to the gate. So leave some space for gate. So middle click on poly. Similarly over here, we'll just leave the space for poly. Middle click on poly. Okay, just for space. The poly of the transmission gate 1, that is the NMOS 1, is connected over here to PMOS. We have seen this in the earlier layout also, how they were connected in opposite way. So this is just the shorting or connected together. So similarly these two are connected. Select from here to here, then middle click on poly. Then again middle click on poly. Middle click on poly. Then connect from here to here. Okay. So these two connected, these two. Similarly we used to do in the earlier cases also. Now in transmission gate 1, you don't need so much. We want, we can remove it. Select the area for 5, short, connect the two sources and two drains with the help of M1 layer. Similarly over here, this is M1, these two are connected, then M1. Okay, this would have been done the way we had thought earlier. Okay, this looks much better than this one. So after connecting the sources and the drains, now we have to connect properly. This is connection to the two sources. This is connected to A, and we know A is a poly. Even though it's a poly, middle click over here. Okay. We can do one thing, just undo all this. Undo. We have to connect with this. So we'll first extend from here. Okay. Then middle click on poly. Then from here to here. Middle click on poly. Then we'll click on metal. We are trying to basically overlap these two. And this region is overlapping of poly and metal, that is the metal contact. Okay, now this is A. We've already given this as A. This is B. This is B. And this is the inverted form of A. The inverted form of A is connected over here to this. So what we will do, we'll connect from here. Middle click on M1. Then middle click on M1. Then from here to here. Then middle click on M1. From here to here. Middle click on M1. Then select this portion, omit it. Okay. Now after connecting the input with this A is connected, then A bar is connected. Yes, A bar is connected, A is connected. Then B is connected, with this. I have to be careful about the connections, about the overlappings. This is B and this is B bar. So let us connect this B bar with this B. Zoom in. B bar with B bar. So this is B bar. This is connected over here. So select the area, then middle click on poly, then from here middle click on M1, then middle click on poly. So here to here there's a connection, then select the area and then middle click on poly contact. Okay, then or we could do in a different way. Just middle click. No, the earlier one looked better. Or we can do like this. Middle click on poly. Okay, this looks better. Here there's a connection between poly and metal. Here there's a connection between poly and metal. Now after connecting with B bar, there's a connection with B. B to this gate. So select from here to here, then middle click on poly. Similarly, select from here to here and then middle click on poly. Okay, this is connected to this gate. This is connected. Actually, B is connected. This B is connected to this gate. B bar is connected to this gate. The opposite gates that are connected. Then A is connected over here and A bar is connected over here. The output is obtained from these two drains. So these two drains have to be shorted. So rather than shorting from outside, we can directly short it from inside. So we can just extend this metal. Okay. We could have directly connected from here to here. We can do one thing. Select the area. Middle click on M1. Middle click on M1. Okay. Now this is the output. So label it as V out. Okay. Now input and output, ground and VDD all are already labeled. Okay, now time to place the contacts. So this is the P diffusion layer, so we have to place the PD contact. Similarly over here, place a PD contact. This is the N diffusion layer, so ND contact, ND contact. Okay, this is one inverter. There's also inverter over here. This is the PD contact. This is also the PD contact. This is the ND contact, and this is the ND contact. After giving the contacts to the inverter, this is transmission gate 2. This is a ND contact. Here again there is an ND contact. Here there is a P diffusion contact. Here again there is a P diffusion contact. Okay, I have to undo this. This is a N diffusion contact. This is a P diffusion contact. Okay, after placing the diffusion contacts, we have to place the substrate contacts or the anvil contacts. So select the area and middle click on N substrate contact, then middle click on N substrate contact. In the ground, we have to place the P substrate contact. P substrate contact. This is the overall layout. It is drawn from the untwisted schematic. Now save this as XOR 4. Okay, we'll name it as XOR 5. If I want to see the DRC, no DRC, then extracting file, that is ext, extract to spice, extract to sim file is extracted. If you want to simulate the sim file, type it sim XOR 5.sim, then watch VA, VB, Vout, display, all the values are X. If I give low value to VA and VB, what will be my output? 0. If I give high value to VA and low value will be the VB, then the output will be 1. See, Vout is 1. Now if I give low value to VA, high value to VB, then my output will be 1 again. If I give high value, VB is already high, VA high, this means both the inputs are high, then my output will be 0. So if you want to see this in an analyzer, ANA VA, VB and Vout. You can see this 0 0 output 0, 1 0 output 1, 0 1 output 1, 1 1 output is 0. So this shows the output of a 2-input XOR gate. If you want to exit from here, then type exit. If I want to see my layout again, I'll type magic XOR 5.mag. So this is the layout. Zoom in. So this is the layout of a 2-input XOR gate. You can see this is one inverter, this is one inverter, this is one transmission gate, this is the second transmission gate, this is VDD, this is ground, and the connections are made as per the discussion in the lecture.